So, guys, hello. I'm Aish Gupta, and I'm starting the new chapter series of current electricity. This will be only divided into three parts. So, this is the first part, and let's start. This course is, the JEE Mains aspirant, NEET aspirant, and the 12th people can follow this. Okay. So, firstly, the topics will be covered, and then the some questions also solved, and after that, some questions answering session will be also there. You for better clarifications, on the numerical. Okay. So, firstly, when we come to know the current, what is current? So, like there, we all know there's the current flowing into the wires. Okay, the electric current. So, what will be the moving of the charges, moving of the electric charges inside the conductor? Okay, conductor is known as electric current. Okay, so just like this circuit, okay, we have this electron going from there to there. We have taken the conventional flowing of current from the opposite of the flowing of electron. Okay, and the charge, we know the unit of the current is ampere. It is a fundamental also a quantity we have seen like in the very first chapter of 11th class, units and dimensions, and it is also a scalar quantity. So now we how we can find the current or charge when there is a graph. So we have know that I is equals to dq by dt. So in order to find the current, if there is a graph between the q and t, we have to find the slope between it like dq by dt. So we will get the current, and if there is a graph between I and t, so we have to find the area of it. So or integrate I dot dt from this lower value to our upper value. So we will find the Q. Okay, so here like examples we have taken like I is equals to dq by dt. We know dq by dt. So I when I is equals to 1 second पे निकालना है. So I is equals to dq by dt. We have to just mm, take the slope of the from the graph, or so how will take the slope of the graph, just differentiate 4t square with respect to the t, so it will gives you the 8t, and just put t is equals to 1, so we will get the current is 8 ampere, and how to get the charge of it. So uh, integral of I dot dt, and 4t square is given. So it will be equals to integral of 4t square of dot dt. It will be equal to 4 t cube by 3. Okay. And just put 0 and 1 on it. So we will get the answer. And this if there is a the value is positive and the second value is negative, so just a1 minus a2 will be the answer. Now we talk about the current density. What is current density? It is a vector quantity first, just tell, and what will be the density like per unit area. So the current per unit area inside the conductor is known as current density. It is a vector quantity, so we have some components j, and this is j dot a will be the I, and it will be the dot product of it, so j a cos theta. Okay, so theta is between the angle between the vector A and A, J and A. So if there is a parallelism between the two, so there will be a theta 0, and if these are perpendicular, so it will be a theta 90. Okay, so now talk about the what is drift velocity. Firstly, this is for the electron, and there is a the random motion of electrons. inside the conductor, and they will acquire a speed which is known as collision speed, and it is the average, you can say average is taken between the time of the collision. So we will find the relaxation time, and then we can find the drift velocity. So the formula is E capital E tau by M, and there is a collision between the atoms. So we can also say this drift velocity and the mean velocity is of all electron, which is drifted towards the terminal of the battery. Okay, there is a random motion of it, so it will be called as drift velocity. So there is a relation between the current, and how can be defined as I is equals to NEAVD. Okay, so VD, we known this, and n is number of electrons per unit volume. Okay, so this will be, you have to learn this relation for the numericals. So we now come to the Ohm's law. So we have, from our childhood, we have all learned the Ohm's law. When current increases and the voltage increases, or the voltage increases, uh, as per it, the current increases. So V directly proportional to I, or I directly proportional to V. And if we have taken this, so V is equals to IR, and if this is taken, I is equals to GV. G is what? G is G is just opposite 1 by R. Okay. So resistance will also depend on the material characteristic. Okay, so it will be equal to rho L by A, which is equals to ml upon ne square tau A, and okay. So there are some extensions of formulas you have to learn just for numerical purpose. Okay, so there is the dependencies of resistance on the length, area, and nature of material and temperature. This is directly proportional to the length. We have seen, we have the here, and inversely proportional to area. Okay, and there is a vector form of Ohm's law also. So we can just write this J as the electric field. J is equals to E by rho. E can be 1 by rho. Conductivity is can be written as 1 by rho. Okay, and the conductance is 1 by R. Okay, you have to just learn or know the analogies between that, like resistance. If 1 by R, then conductance, uh, resistivity, rho, and just opposite of is conductivity. Okay, so this is the formula coming out to be there. So we know I, and if we divide by both side by A, so I by A, we know it is current density. Okay, so there is a new formula coming, and E is square tau capital E by M. Okay. So, hello guys, I'm Ayush Gupta, and I am starting the new chapter which is named as Current Electricity. So, I will be covering this chapter in a three parts. So, this is the first part of the chapter. So, this is like for the 12th people, or the JEE mains or NEET people who was a dropper, or preparation is he is or she is doing preparation. So let's start now. So, what comes in our mind when we talk about the electric current? When we talk about the talk about the current. So, electric charges in motion constitute a electric current. How? There is a flowing. We all know there is a flowing of charges inside the conductor. So, it constitute a electric current. So, any medium having free charges, free electric charges is a conductor of electricity. We all know, and this E is equals to V by L. Yeah. So, what is electric current? So, rate of flowing of charge is known as electric current. So, it is equals to dq by dt. This one. So, what is I convention? And there is a circuit here is given. So, I conventional is the flow of electron is opposite to the I conventional. So, we taken the I conventional opposite to the charge of flowing of electron. So, if electron goes from here to here, the I conventional from the opposite of it. Yeah. And what is the unit of current? Ampere. It's A. And yeah, yeah, I've done this. So, so where we was, we are discussing some properties of for it. So if a charge is moving in a in a circular motion, of radius r and speed v with time period is equals to 2 pi r is equals to v. So the current we get is by the q divided by t. So and the v t we have known is the 2 pi r upon v. So we will get the time, we will get the current, in the moving in a circular motion, and electric field outside the current carrying conductor is zero, but inside a conductor is V by L. We all know, field outside the current carrying conductor is zero, like it is act like a neutral neutral thing, so it will be zero. Yeah. So we will calculate. We have to calculate the charge to cross section area of the wire in the first 10 seconds. So we have given the T. T is equals to 10, and I is equals to 2 plus 3t. So we have known this I is equals to dq by dt. Okay, so we have to find the q. So we will integrate the current with dot dt. Okay, so it will be like 2 plus 3t dot dt. So it will be equal to 2t plus 3t square by 2, and you have to just put the uh, like values from 0 to 10. Okay, so 0 will be, if we put 0, it will 0, so we have to put only 10. Okay, okay, so 300 divided by 2, so it will be 170 ampere. Okay. And here we can directly, what is our current through the wire decreases linearly from 4 ampere to 4 ampere to 0 in 10 seconds. Calculate the charge flown through the wire during. We have to again calculate the, the current. So we how we get the charge first. So charges we get by the area of this triangle. So we can find the 10 into uh, half into 10 into 4 divided by we will get the is equals to 2 ampere. Okay. So here is the vector is given current density. Find out. Find the rate of change of flow through the cross-sectional area as S is equal to 2I plus 3J. So we have known like what is the formula for current is equals to J dot A. So we will get the the dot product between these, and we have known if the same I dot I, it will be it will be uh, one because it is a dot product. So the theta is zero, so cos theta will be one. Okay, so we will same find the current. Okay, so I'm solving this. Okay, so either J is given, so we will directly, multiply the jth factor of it. Okay, so 3 into 2 into 10 to power 4 into 10 to power minus 4. So this will be gone. Only 6 ampere will be the answer. Okay. Yeah. So if we have a condition like we have to, find the total current passing through the wire. So like there is a derivation behind it, but I'm not going through it. You can go through some books and all. So it can be, I just tell you the how it works. Okay. So we have DI. We have find it the DI like how. We know the J is equals to KR and I is equals to J dot A. Okay, so we have find sorry yeah J dot A. So we have find the J into A 2 pi R dr cos theta. Okay, so we will integrate the di only from 0 to R position. Okay, so we will get the current. Okay, so there is a VI characteristics like Ohm's law. Obviously, it is gives the same. So linear V. What is linear VI characteristic? So it will. It is basically depends on the Ohm's law. So I will directly proportional to V. So it will I is equals to G by V. And if we, V if directly proportional to I is equals to IR. So I is and R, R is equals to 1 by G. So it is obviously the same how this is how you learn. Okay. So it depends on you, how you learn. Okay. So it is the Ohm's law. Okay. So V directly proportional to I. So there will be a directly proportionate graph. Okay. Okay. And if we have a graph of I by A, so it will give you the 1 by R, or you can say the G. Okay, so there is a second graph also for non-linear VI characteristics. Like there is a temperature change. Due to the temperature change, there is a change in the flow of electrons, protons, and all. So it will happen in the like semiconductor. You will learn in G in the semiconductors unit. Okay, so you don't have to take any tension here. You just have to learn here. Okay, so, semiconductor, this graph is for, and it is, these are graph for other semiconductor. Okay. Okay. So, what is mobility? Okay. So, mobility is something defined like drift velocity per unit electric field applied. Okay. So, mobility is that. Like, how mobility. So, how it, go from one position to another. So, like, it is just defined as VD in a electric field applied. Okay, so we have known E capital E tau by M. So divide by E is equals to E tau by M. Okay, so VD is equals to mu E. It is a special. You have to learn this formula for numerical purpose. Okay, you have to learn all the formulas out there in the chapter. It will be important for the boards as well and for the JEE as well. Okay. So, how is the resistance and resistivity depend on the temperature. Okay, so on increasing the temperature, there is a increase in the rate of collisions. Okay, okay. So you know there will be an increase in the resistivity and resistance also due to that. Okay, so how it how this works. So this is a formula we all know. R is equals to ml upon ne squared tau a. You don't have to take tension. You have to just solve numericals. You will get to learn all this formula by it. Okay. So this is the relation between it. RT is equals to R naught 1 plus alpha T plus beta and delta T square. These ignore, you can ignore these. These are the higher order terms. So it you can ignore. You can learn this only this also. Okay. You don't have to take such any much tension. Okay. So what is this graphs look like? It is looks like m mx plus c. Okay, so there is a c constant extension is there. Okay, so it will be for some lower temperatures and for very high temperature. There is a change in the graph. They are not directly proportional or like straight line graphs. So it will change, their nature also. Yeah, so like there is a relation given. If the increase the temperature, R increases, the slope increases, and the just opposite of it. Okay, so yeah, I have given these two graphs. You have to just remember what it is saying by this graph. Okay, so this is basically the same I have previously told you about. You can see and learn it properly. Okay. So there is a color coding of color resistance, Okay. So it is very easy topic. So you have to just color code the carbon resistors. Oh, okay. I just tell you, this is very easy. You can see and you have to learn. So I just tell you to learn simplest line. B.B. Roy, Great Britain, very good wife. So the first is it is given B B R G D. So it will gives you the name of the color and it's multiplied. You have to learn. Tolerance is only in the gold, silver, and no color. So how will this work? So there is a 3 and 4 lines is given on the register colors. So L1, L2, L3, L4. So these are the L1, L2, L3. You have to L1 and L2 is the number. This one ये वाले and the L3 is the multiplier. Okay, and if there is a tolerance given, so you have to plus or minus plus minus this tolerance. Okay, so if L1 L2 red silver, so red is given 2. So 2 into 10 to the power 2 plus plus minus given is silver, so plus minus 10. Okay. So this is a question also asked in the JEE on it. If a wire is, this is also a concept you have to learn this. If the wire is stretched to n times of its original length, so what will be the new length of the of the wire? So it will be equal to n square. How it is like uh, resistances depend on the length also. Okay. So how it is? We all know R is equals to rho L upon A. Okay, and R square it is depend on. So if we stretch the n, so it will be a R by n. Okay, so n goes into multiplication, so it will be equal to n square R. Okay. Okay, so we now starting the combination of resistors and Kirchhoff's law. This is a very important topic in the current electricity topic. So you just have to ध्यान दो अच्छे से. Okay. So we all know in the series combination it is equal to R1 plus R2, and if we have to find the current, so it will be equal to voltage divided by R1 plus R2. Okay. And if there is n resistor, so will be NR, so n times it will be. Okay. And all the things are just opposite in the parallel combination. 1 by R is the sum, and this is if the every resistance is equals to NR. Okay, so NR is in the denominator, so it will go up. Okay, like it will go in the up in the answer. Okay, so it will be equals to R is equals to R old register upon divide by n is number of resistors, n resistances. Okay, so I1 is equals to, you have to learn this, you can learn this. This is like shortcut formula also. Not shortcut, but you have to just, learn to, get easy calculation fastly. Okay. So there will be also a mixed grouping also. So I will be start this topic like in the next session. So now we start the topic cells, combination of cells, electrical, heating, and power. So basically, we start now. So a cell. What is cell? Cell, you are all गाड़ी में देखा होगा. So a cell converts the chemical energy into the electrical energy. We are all seeing in the wall clock. There is the energy. There is a cell, 2A power battery. So it will convert the chemical energy into electrical. And okay, so how the EMF and voltage is different. We will see this. You have some confusion how it will how it will different. Yeah, na? Okay, we will see. Okay, firstly we see the what is the internal resistance. So the resistance is offered by the electrolyte of the cell when a current is flowing through the through it. So it is known as the electric resistance. So there will be some resistance offered by electrolyte inside the cell. Okay, so it is uh, internal resistance. Okay, it is denoted by small r. Okay, so so we now starting what is E and V or something. Okay, so what is potential difference when a cell is drawn through a cell, when a current is drawn through a cell, okay, or supplied to it, there is a potential difference between the two, two terminals. So that difference is called the potential difference. And what is E? So when the current not drawn, when the current is not drawn from the open circuit, it is, so that voltage is called the EMF. Okay. Yeah. So the EMF is always more than the voltage. Yeah, because some current is drawn from it, and there will be a internal resistance which has taken some energy. So the V is equals to E minus IR if there is a discharging. Okay, and if there is a charging, so V is equals to E by R, E plus I. This is like combination of cells. So in the series combination, we all know all the potential internal EMF add, resistances add. Okay, and in the parallel, just opposite of it, everything. Okay, I've written clearly. It is uh, divide by sum of E1 upon R1 plus E2 upon R2 is to the En upon Rn. Okay. So now we talk about the very important laws in this chapter. Kirchhoff's law. There will be a two laws of to for the determination of the potential difference in current in the different branches. If there is a multiple branches given, like very complicated circuit is there, so we have to find just the potential difference in the one part in the second branch. So how will let's see how we'll find the so the first Kirchhoff's law was that all the current is coming is equal to the current outgoing. Okay, so the sum on some point it will be equal to you can say it is zero. Okay, of the incoming and outgoing. Okay, so if we take incoming as plus, outgoing as minus. Okay. So, okay, and so for convention purpose, the incoming current is negative and the outgoing is positive. Okay, so how will we find this current in the circuit? Okay, current in this branch. Okay, so we have like we given 4 ampere and 3 ampere here, so it will be to constitute 7 ampere current in this whole branch, and here 2 ampere is going. So what is here? Okay, so what will be current is here? Okay, so it will be like 5 ampere. It is what will be there in a the third branch is there. Okay, so 2 plus 5 is minus 7, so it will be 3.7. Okay, so what is second law? It is also known as the loop law. Okay, so what it says, the voltages across the loop of all components, the sum of these is equal to 0. Like P1 plus P2 plus P3 is equal to 0. Okay, so you have to just learn the sign conventions. Okay, if there is a voltage plus and minus. Okay, from going here to here. Okay, here to here, so it will be taken as negative. There is a drop in the potential. Okay, potential drop is there. Okay, and if there is opposite, so it will be taken by plus. And if the current is in the direction of the loop, we will take it as a minus. And if this the loop and current are opposite, it will be taken as plus. Okay, so there is a question out there in the KVL, which is known as Kirchhoff's law, second law. Okay, so there is a circuit given. So we will, firstly determine the current in the branch one. Okay, so we will, you know, 1 and 2. Okay, so we have taken this loop like the clockwise direction. Okay, so there is a 1 and 10. Firstly, we will write the 10 plus 10. Okay, so we have written first 10, and I and loop are in the same direction, right? Okay, so we will take in at minus I into 2. Okay, and the same thing applies on the 4i. And for the second loop, and for the second loop there is a 20 volt will be minus. Okay, and plus 4 into I1, and there will be a second you can take in as I2. So you will find the I2 first and then I1, or you can just I minus I1 it is. Okay, so solve there is a two variables and two equations. You can have to find this I and I1, and you will find the I minus I1. Okay, and the same formula is applied. Like it is a very important question, like how you solve the nodal analysis. So you have to just take a node at the specific point, the middle point of all these circuit. Okay, so sigma I at this junction will be zero. Okay, so you have to just taken in mind. You have to take the sigma I will be zero. So you will take to I of the whole circuits. Okay, so there is first x minus 10. If you taken as x, so it will be x minus 10 upon 2. It will be a current constitute in this branch. Okay. And in this branch, it will be 8x minus 0 here upon 4 in the second branch. And in the third branch, x minus 20 upon 8. And it's will equal to 0. We will, find the x out there. And after x, we will find all the things, all the current in the branches. Okay, you have to just solve these problems, and if there is a problem, you can comment me out there. I will drop this PDF out there, so you can solve these questions as your practice. I will not solving as I have to complete this part firstly. So we will certainly discuss many problems and after this whole theory part. Okay. So this is a question one we have taken the question. Find the value of n. Okay. So we have to find the value of n equivalent resistance for given between P and Q is equals to nr by 3. Find the value of n. So we have to find the n basically. So how we can do? Okay. So we have seen this one, and this one is parallel. So, okay, so this is R by 3, this is R by 2, this is R by 2 in series. Okay, so we have to take the sum and find the n. This is a very easy question, easy one. And for it, we have seen this points and this points here. Okay, so if this point goes on this one, you know, so we can move here to here. There will be no problem moving these points to these points. There is a certain rules. You do not have to move a point. You have to just move the point from one point to another. There will be a neutral thing happen. There is nothing, short circuit happen to it. So it will be okay. If you do this point to there and this point to there, so these all things be in parallel, one by R1, one by R2, one by R3. Okay. This is another one you can solve as that. Okay. Okay, these are some higher order questions you can solve for JMAs. For 12 purpose, it is okay, fine. This is a very important for very question. These all the questions I will solve in the question answering session. Okay, you can put your doubts in the comment section also. Okay, so what is the electrical heating and power? Okay, so what is the cause of heating? Okay, so I've told you there is a collision in between the electrons. Okay, inside the lattices or in moving in the during the moving of electrons. Okay, so there will be a Joule's law of heating. Okay, so you have known I square R. Okay, so it will also equals to VI into T. Okay, so you have to just learn this unit 1 kilowatt और into कई बार बच्चे कंफ्यूज हो जाते हैं कि किससे इंटू करें सो तो आप लर्न कर लीजिए, आपके लिए बेहतर होगा। 1 BTU इट्स फाइन, आपको नहीं आता, कोई गिवन होता है कहीं कहीं। एंड P इज इक्वल्स टू VI इज इक्वल्स टू I स्क्वायर R, है ना? ओके, पावर इज इक्वल्स टू, है ना? एंड द पावर ट्रांसफर टू लोड बाई सेल इज इक्वल्स टू I स्क्वायर R। I क्या है? E अपॉन R प्लस स्मॉल r। ओके, let's see the series and parallel combinations of the resistance like bulb. Okay, so total power will be like in series, uh, 1 upon Pt is equal to 1 upon P1 plus 1 upon P2. Okay, so if there is an bulb, P divided by N, and so in the series combination, the brightness will be, depend on the power, and power depend on R, and R depend on P, 1 upon P rated, which is given लिखा होता है वहाँ पे। ओके, सो जो लेस वॉट का बल्ब होगा, इस हिसाब से वो ज्यादा ग्लो करेगा। ओके, फॉर द सेम पावर। ओके, and in the parallel combination, P will be equals to P1 plus P2. Okay, so the brightness directly proportional to power divided by directly proportional to 1 by R, directly proportional to the brightness. Okay, पावर कंज्यूम्ड क्या होगी? ज्यादा होगी, तो ग्लो भी ज्यादा होगा। Okay, so if there is this is an important like JEE, sometimes they ask in JEE if a heater boils m kg of water in time t and another heater boil the same amount in the t2, they are both connected in series. So what will be formula, and if they are connected in parallel, so what will be the time, total time? So t in series will be equal to the sum of these, and in parallel there will be 1 by T1 plus 1 by T2 is equals to 1 upon T. Okay, so I will solve all the numericals in the in the solving question answer solving session. Okay, so we have covered the first part of this current electricity. So I hope this was a great session, and if you have any problems, so you can comment me down there, and if you needed any help in the JE, you can reach me out there. I've given all the links there. You can reach me out there if you have any problem with some course problem, or study problem, or like counseling problem. Okay, you can reach me out there. So I will be starting the part one. I will also release the part second soon. Okay, so thank you everyone for being here. Okay, so thank you so much.